Welcome to your Science News Update. All right, let's dive right in with our top story tonight, and it's a big one. A truly remarkable discovery coming from the depths of space. So, astronomers using the good old Hubble Space Telescope have just confirmed something they've never seen before, a totally starless gas cloud they're calling Cloud 9. Think of it like a fossil, but from the very dawn of the universe. It's giving us this incredible, unprecedented peek into how galaxies are actually built from the ground up. Now, the official name for this thing is a relic. Yeah, I know, it's a mouthful. It basically means it's a failed galaxy. Imagine a giant cloud of primordial gas loaded with dark matter. It had all the ingredients, everything it needed to become a galaxy. But for some reason, the stars just never switched on. And the stats on this thing are just wild. The hydrogen gas itself, it weighs about 1,000,000 times the mass of our sun. But get this, it's all being held together by a halo of dark matter that weighs a staggering 5 billion solar masses. So what happened? Well, that immense gravity from all the dark matter actually stopped the gas from clumping together enough to form stars. It's like it was frozen in time, leaving us this perfectly preserved relic from the early universe. Okay, let's bring our focus a little closer to home now. Because it turns out 2026 is really shaking up to be a record-breaking year for all things space exploration. The European Space Agency, or ESA, is kicking things off with a record budget. We're talking 8.26 billion euros. And you can see their top priority loud and clear. Almost a third of that money is going straight to Earth observation. It really shows you there's this growing sense of urgency to use our eyes in the sky to monitor climate change, keep tabs on our environment, and just generally protect our home planet. So what does that huge budget get you? Well, it's funding a record-setting 65 new missions planned for this year alone. That's going to make for one incredibly busy and hopefully very productive year for the agency. And just to really drive home that focus on our planet, get this. A staggering 48 of those 65 new missions are all about Earth observation. I mean, that's a huge chunk. It really underscores this major global shift towards using space to get the critical data we need to manage our world. Okay, we've got some breaking news coming in from low Earth orbit. For the first time ever, NASA is actually conducting a medical evacuation from the International Space Station. We're hearing a member of Crew 11 has developed a serious medical condition. They say it's stable, thankfully, but it means the whole crew is making an early trip back home to make sure that astronaut gets the care they need. All right, let's bring our focus back down to Earth, where some fascinating new research is shaking up what we know about our planet's deep past and its very present challenges. You know, when we think about deforestation, we usually picture huge, sweeping areas of land being cleared. But a new study posed a really important question. What about all the little guys? All those small, often overlooked patches of deforestation? What's their real impact? And the answer is, well, it's pretty startling. Researchers used high-res satellite images and found that these tiny clearings, we're talking less than 2 hectares each, only make up about 5% of the total area that's been disturbed. But, and this is the crazy part, that tiny 5% is responsible for a whopping 56% of the net carbon loss. It's a huge, hidden driver of climate change that we've been underestimating. And sticking with Earth, but going way, way back in time, a new analysis of some incredibly old 3.7 billion-year-old rocks from Western Australia has completely rewritten the timeline for when our continents first started to form. It looks like it happened hundreds of millions of years later than we originally thought. Okay, so we've gone from the cosmic scale all the way down to the planetary. Now let's zoom in even further, right down to the microcosm of human health. Scientists have been making some really critical advances in how we understand and maybe even treat some of our toughest diseases. So here's a huge breakthrough in cancer research. Scientists have pinpointed this vicious, self-sustaining loop that drives one of the deadliest forms of pancreatic cancer. It works like this. First, a protein called SRSF1 ramps up production of another protein, AURK. Then, AURK acts like a bodyguard for a cancer-causing gene called MYC. And what does MYC do? It turns around and boosts the levels of SRSF1, starting the whole aggressive cycle all over again. It's a nasty little circuit. Over at gene therapy, there's a new twist on CRISPR that's pretty amazing. Think of it less like a pair of scissors and more like a dimmer switch. Instead of actually cutting the DNA, which can be risky, this new epigenetic editor just removes the little chemical off tags on a gene. It basically flips the switch back on without ever changing the fundamental DNA code. It's a much gentler approach. Meanwhile, some really intriguing research into aging has identified specific proteins in young blood that seem to fight the kind of brain inflammation that's linked to cognitive decline. Now, these are mouse studies, but they found that proteins like PF4 and Klotho can actually slow down and maybe even reverse some of these age-related changes. It's fascinating stuff. And finally tonight, let's look to the future. We've got a truly historic milestone in the long quest for clean, limitless energy. We're talking about nuclear fusion. So, for decades, fusion research has been running up against this wall, a theoretical barrier called the Greenwald density limit. You can think of it as a speed limit. It's the absolute maximum density of superheated plasma you can contain before the whole thing becomes unstable and just fizzles out. Well, in what is just a stunning development, China's East reactor, their artificial sun, has just shattered that limit. They've managed to achieve stable plasma densities that are 1.65 times higher than what was thought to be the absolute maximum. This is a massive leap forward, and it could be a huge step towards making fusion energy a real, practical reality. So, when you step back and look at all the news today, there's a really clear theme, isn't there? From these ghost galaxies at the edge of time to the tiny vicious circuits inside a cancer cell, it's all about revealing the hidden rules, the fundamental mechanics that govern our universe and even our own biology. And that's your science news update for today. We'll be back with another one for you in 24 hours. If you found this useful, hey, we'd really appreciate it if you'd like and subscribe. Thanks for watching.